Hello students, imagine a road without a traffic signal. How confusing it would be, right? Today we are going to learn the traffic light static module experiment using the SCADA Trainer Kit, which helps maintain road safety. The main objective of this experiment is to control vehicle movement. When we press the start button on the HMI screen, the system begins to operate. Observe carefully. When the green light is on for direction 1 and direction 2, the red light must be on for directions 3 and 4. After that, the signal changes through the yellow light. The real secret behind this automation is timer logic and interlocking. In the ladder diagram, notice how timers like T2 and T3 are linked to each other. As soon as one timer finishes its set time, it activates the next signal. This is the key concept of the experiment. Before using the trainer kit, carefully check the input and output addresses in the addressing table. Also ensure that the timers are set with the correct time values. Now, let's perform this experiment practically on the trainer kit and observe how it works.
Hello everyone, today we are seeing the PLC kit. So we will see an operation of traffic light using a static module. It looks like this. Now I will connect the connections through these input and output modules and by using a PLC program. The PLC program has been done already, so I will show how the connections can be done. So for that we need some patch cords, a screwdriver and a static module of traffic light. So before going that, let me explain about static module. It has 24 voltage ground, a start and stop button. As you can look here, it is a 4-lane traffic light. It has red, yellow and green. So red is of 60 seconds, yellow has 5 seconds and green is about 30 seconds. So even you can keep as you think so. So let's begin with connections. So before going to connection, you should always see, you should not attach the ground and 24 voltage before. You should attach it at last, because to avoid the short circuits and default currents.
Now, let's begin the programming part.
So let's start with the ladder logic. So let's open the Siemens software of version 18. So wait for the process. So let's create a new project and let's add the project name as traffic light. And then click on create. So I have already a traffic light program. So I will write as traffic light 1. If you don't have, then you can only just write traffic light. Then click on create. Then wait for a process. Then click on configure a device. Add new device. Then as per the module, first click on controller. Then as per the module, I am clicking on A7-1500, then CPU, then last third option unspecified, then double click. So we have configured the PLC. So let's accept its credential. So click on detect. So now let's search our module. Click on start search. Then it will display the module name. Once it displays, to confirm, click on flash LED. Click once again, then detect. If it detects the PLC, then connect. If it detects the PLC will blink. So now next. So now next, now give this full access to PLC. Even click on next, finish. Then afterwards click on this arrow button. Then go to program blocks. Then add menu B. Now let's start writing the traffic light program. So let's add NO first, that is start button, then ENC, that is stop, and then output. Then to latch this, let's take a latching symbol. Then let's add an NO. Then let's connect it to up. So to connect, even you can drag it or there will be a specific symbol. So I will drag it. So for this, now again let's take an NO, means for continuous cycle, to latch. Now an NC, then a timer. For timer, even you can take directly or you can follow my steps. So write the T on timer, then click on it, then double click, then OK. So for every timer and for every ladder logic, you have to follow same steps and you have the same memory bits. So let's take NO, then NC. So we have 3 timers, so we have 3 outputs, so we have to add 3 timers. So even all 3 timers will be T on only. Then click on OK. So even here same, add the NO, then timer, select the timer, then OK. Now let's let ladder logic for this all 3 timers. So for first timer, let's take the power, that is NO. Then to start it, then to stop. This is for red. Then common connection will take as NO. Then for yellow, again let's take NO. Then to off now red, let's take an NC. Now yellow output. Now common connection, that will be taking NO only. So let's latch it to green. Let's take NO. To stop yellow, we'll take an NC and then green output. So so we'll be giving names and tags to through PLC tags, which you can see beside. Click on PLC tags, click on show all tags. You will be saving this interface. So let's give the name as start, and then enter. So let's give this for stop.
So this has red as an output, and then enter. So while giving, see, now our 3 LEDs are output, so change the addresses. So let's give this as Q 4.0. Now yellow. Now same addressing Q 4.1. It will assign automatically. Even you can change it by manually. Now green. Then enter. Even it takes automatically. And let's go back to menu B to assign this all addresses to the ladder logic. Click on menu B. So our first one is NO, that is start. So click here and click on this option. You will be seeing the addresses. Now click on start button. It's assigned. Then click to next. You will be seeing the start is assigned. Now follow the same steps to all. This is our stop. Click on stop. Now here we have to give an memory address. So let's make address for this. Then again go to PLC tags, or you can click on menu B. It will go back to same page. So address here as output. Then enter. Then this is my memory address. So M0.0. I will take it as. So you should see the input are in I and output are in Q and memory address are in M. Then these are the PLC standard form. So let's go to ladder logic program. Then click here this option and search the output, that is your memory address. So my output is this. I will click here. Now I have connected in this latch form. So this same output will come at the downside. So you have to give same address, follow the same steps, and it's done. So to this, to this all programs or all ladder logic, we are be using common memory address and common connection as an output. So assign all it to all. After assigning here, even you have to assign to ladder logic also. Same. Click here. Even you can connect it here also, because these are all have common connections, as you can see here. If you want, then you can remove it, or even you can make it separate. So I will make it separate. So we will assign the same address to all. Now okay. Now let's add a timer. Before adding timer, let's make our all the things, means I mean all ladder logic before. So before going this here, let's go down. Even you can change the data block, means timer name. See, follow the steps as I shown. I will assign it as timer 1. Then click on OK. Right click on timer, then rename data block, then assign your timer name as per your application. I will rename as timer 2. Follow the same step. Click on data block, timer 3, then OK. So let's add, click here, then go to this option. Now let's add the red ladder. So we will assign it as timer 1. So this is input and output. So our all timers are at output side, so we will assign it as output only. So click on Q. Q is nothing but your output side. Then at last it's my output. So my outputs are 3 LED, that is red, yellow and green. So this is red. So check the red and click on and select it. So now our red light is assigned and our timer is assigned properly. So now let's assign yellow and then green. So now we have to on the yellow light. So we will assign the timer 2. Sorry, timer 3. Even it is Q. So when we will start yellow, the red light should be off. So we'll off the red here. Follow the same step as I shown before. Then to off red, we have to off the timer 1. So now we will turn on the green. So our T1 is red, our T3 is yellow and our T2 is green. So now let's assign here T2 has green. Even it has Q. Then if we start green, then even we have to off the yellow. So let's off the yellow. So I will be having here timer 3 as Q. So let's check. So let's check the so let's cut. Okay, let's add the timer 3. Follow the same steps as I shown you before. So let's add timer 3. Even it has also output. So after adding it, let's check the ladder logic once again. So our yellow is proper. So now let's assign the timers at what time it should be stop. So here the timer 3 going to stop, means when red starts the green should be stop, means timer 3 will be stop. Then yellow starts, then red should be stop, that is timer 1 as output. When green starts, then yellow should stop. See, if you will not add input as address, then it will show an error. Then simply click on it, go to this option and assign as value input or output. So in our application it is output, so assign it. So after assigning, as per the traffic lights standard, number 3. So as per the traffic light standards, we will going to add. So our red will be minimum for 10 seconds. So add 10s and then enter. So it will assign a address automatically. Even you can add it here as a MD27 or you can keep it as empty. So I will keep as empty. Then assign here it as 7 seconds. Simply write 7 and then S, then click on enter. Even this will also keep it as it is. If you want, you can change that. Then I will keep the green as 5 seconds, then write 5S, then enter. Even this I will keep as it is. So I will show you the whole program. See, this traffic light whole ladder logic look like this. This is the whole ladder logic of traffic light. So first you start, stop, then all, then common memory address, then all the timers are assigned properly. Check the ladder logic twice if you are not confirmed. Then after confirming, go to compile. Then compile it. Compiling nothing but analyzing your program. So let's check our program. So here there is a no cross mark, means it is our program is fully corrected. So let's check once again. See, then go download to device, means your program will be going to download to your device. After compiling only you should download the program to your device. So this interface will open, then click on start search to search our module. It will take us some time, wait for a while. Afterwards configure the PLC, follow the same steps as I shown. Click on flash LED to confirm the module. Wait for a while. See the PLC module whether it is blinking or no. Then load. Load is nothing but it's writing, means it's sending our whole program to PLC. Then continue without synchronization, means nothing, it is asking for confirmation. Just click on it. Then it says it's asks some permission, that is no action. Make it as reinitialize. Reinitialize means nothing but it is asking double verification. It's like an authentication to ask whether the programming is to be add or no. Yes, even we want to add the programs and all. So let's load it. Click on load. Then afterwards you can see here the caption is loading completed with 0 errors and 0 warnings. The errors should be 0 but warning should be minimum 1 or 2, not more than that. So you have to check your program twice and thrice that the warning should be not more than 3 or 2. So afterwards click again download to device, then load, then finish. Follow this cycle till the finish option comes. Then let's drag it down. Now you can see here there is an spectacle object that is named as monitoring on off. Click on it to go online. Even you can click on direct on online to go online. See, even you can check our simulation has been started. So according to my PLC module, this PLC module does not support I0.0, so I will rename it as 10.0. Sorry, not 10.0, 10.1. So I will rename it as I 10.1. After that I will rename it as stop as I 10.4. So if you will address the same addressing to more applications, then your addressings will be overrated. So you should see where the your tags are used many times or no. So afterwards, to go back to main page, you have to clean your main OB. This is a shortcut key. After clicking it, if you will change anything in your program, each and everything, if you will change, then again you should compile, check your program whether it is correct or no. Then again you should download to PLC. So you have configure once before only, so it will show direct interface to load. So let's click on load. Click once again to download to PLC because the finish option has not came. So let's click on download to device once again load, then finish. So okay, now let's click on monitoring on off, or either you can click in go online. So this is my start stop. see the whole simulation looks like this. Let's start the program. See here, my red is on, then my yellow gets on, and my red and green is off. After the timer gets end after 7 seconds, then my green starts and my red and yellow gets off. So this is how basically traffic light logic looks, and the connection can be done through PLC with static module in one way. For two-way, three-way or four-way, you can follow the same steps, but the timers and the outputs will be more according to the lane of the road. So this is the basic program, as you can check. Thank you.
Now, let's begin the connection part.
So this is my input side, this is my output side, this is my 24 voltage, and this is my neutral, means 24 negative. So I will be using red for 24 voltage. So black for ground. As per the word skill standard, you should use 24 voltage and ground for same colors. So as per the word skill standards, the red color is used for 24 voltage and black is used for black. So I prefer to use this only. So this is 24 voltage and ground. This connection we will be doing last to avoid any short circuits and any current faults.
Listen closely, students. The golden rule in any electrical lab is to always connect your power source, the 24 volts and ground last. If you wire a live circuit, an accidental slip of the patch cord can cause a direct short. This will instantly blow the protective fuses or permanently damage the PLC's internal circuitry. Safety and sequence go hand in hand.
So for start and stop button, I have input models. This. So for start and stop, I will use that. So my stop button is I 10.1. Even you can use any another input side as per your condition. So I have used green patch code for start button and a red patch code for stop button. See, as you can see here, even they have mentioned for green has start and red for stop. So please follow these steps. So as we know that the green light has green color, so I will use green patch code for it. So this is for green, means I mean for green LED. So my green means these are my all are output. So this all three LEDs connections going to my all output models.
Let's pause and understand the logic happening here. Start and stop buttons are inputs. They send physical electrical commands into the PLC. The traffic lights are outputs. The PLC processes your pre-written program and sends 24 volts out to the exact output address, like Q4.0, to turn on a specific light. Never mix up your input and output modules.
That are 10.0, Q4.0, Q4.1 and Q4.2. Okay, now we are connecting blue wire for Q4.1. That will be my yellow light, means it will blink for 5 seconds. So for red LED, I will be using a red patch code, and for that I have addressed 4.2. See, while connecting, you have to observe that both the patch codes have some difference, and this end should be go to static model, and this end should go to my PLC trainer kit. So as I told, my red wire means Q4.2. I will be addressing, means I will be connecting to my red LED on the static panel, that is this side, and my blue, that is Q4.1. I will be connecting for yellow, means that is middle part in static panel. So when you connect, check once or twice by grabbing patch cords that they are fit or not. If it is loose, then your application won't work.
Do not ignore loose connections. A loose wire isn't just a simple mistake. It introduces high contact resistance. In sensitive PLC inputs, a loose connection can cause signal bouncing, making the controller think a button is being pressed rapidly when it isn't. Always ensure a tight, secure fit to guarantee technical precision before powering on.
So if you are done with the all connections, then you can connect the ground and 24 voltage. So before connecting any of the things, see the 24 volt patch cord has got loose and it came out. So you have to check this twice before doing. So as you all can see here, if you have done a correct connection, then you will get an indicator shown here. So my program is off, so no LED has been blinked. So when I click on the start button, so as you can see, the red has been started. After a few seconds, yellow, and then green.
What you are seeing right now is the PLC executing timers in its internal program. The moment the start condition is met, the first timer counts to 60 seconds for the red light. When done, it automatically triggers the yellow light timer for 5 seconds. This is pure sequential automation, replacing what used to require dozens of physical mechanical relays.
So when I press stop button, the whole application will stop. So you can keep delay as per your application or as you want. So this was a basics traffic light application with static model. Thank you.